Yo, 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 yo. We're about to get on to this hairy guy right here. Strap on. Here we go. We're going to analyze the graph of y equals 4 cosine squared of x minus 2 within this interval from 0 to 2 pi. And check this out here. We're going to be finding the zeros, the period, and the amplitude. Okay, so let's go ahead and start with finding the zeros. And if you're going to find the zeros of any graph, we always set y equal to 0. So I'm just going to say 4 cosine squared of x minus 2 equals 0. I'm going to set my equation equal to 0. I'm going to find my zeros. I want to know, where does this graph cross the x-axis here? Okay, well, check this out. We have 4 cosine squared of x minus 2. They both have a 2 in common, right? So that means I'm going to factor out a 2. So I get 2 cosine squared of x minus 2 equals 0. Now, look back. That's right there. Look back on your formulas, on your double angle formulas. This right here, 2 cosine squared minus x, this right here is cosine of 2x. Look it up. That's what it is. This right here is just 2, it's cosine of 2x. So I can replace everything in the parentheses with cosine of 2x. Okay, so just look that up, and that's how I'm making that substitution right there. All right, well, if I divide then by 2, I get cosine of 2x equals 0. So just like we learned from last section, the way that we handle this is we say the cosine of what? Think of this as just like theta. Cosine of what is 0? The cosine of what is 0? Well, there's two places where we get 0. One is pi over 2, okay? And I'm going to set 2x equal to pi over 2, okay? And the other one that gives us 0 is 3 pi over 2. So but remember, if this whatever is inside of, or what we're taking the cosine of, that needs to be set equal to our radian. Okay, so 2x equals pi over 2, 2x equals 3 pi over 2. So if I solve for x here, x is going to be pi over 4, and I got that by multiplying both sides by 1/2. Okay, I'll just show that right here. If I multiply this side by 1/2, multiply this side by 1/2. Same thing over here. Multiply this side by 1/2, multiply this side by 1/2, and our answer then becomes 3 pi over 4. Okay, so let's see here. We have the x values of our period. Let's see if this makes sense here. If you go back to what our graph is right here, okay, y equals 2 cosine of 2x, okay, meaning just dealing with just the left side. We can't deal with this graph because we divided by 2. So if you just take the same graph right here, so far everything up here is the same, but then we kind of changed it when we divide by 2. So we want to look at this one. What's the amplitude? What's the amplitude right here? Well, isn't the amplitude always this value right here too, right? And so that means my zeros are going to be pi over 4, 2, or negative 2, and then 3 pi over 4, and then 2 or negative 2, right? Because we know that it could be positive 2 or it could be negative 2, because the amplitude is an absolute value right there. Okay, so and then we'll go over what the max and min here in a minute here. So we know pi over 4 is 0 and 3 pi over 4 is 0, right? Okay, so those are our x-intercepts, right? Okay, so this right here will be our zeros. So we got the zeros, we got the amplitude. What about the period? Well, the period, again, is 2 pi over b, right? That's for any sine or cosine, it's always 2 pi over b. And our b value is always the one we're taking the cosine of, the coefficient of our variable. So that's 2 pi over 2, which means that our period is just going to be pi. Okay, and so we just found all these little nuances right here. And if you were to draw just a sketch of this, which I'm going to attempt to do right now, this will go up to 2, this will go down to negative 2. So let's see here. I know that we have pi over 4, pi over 4. And I'm just going to go in increments of pi over 4 here. So that would have to be pi over 2. And then 3 pi over 4. And then this one right here would be pi. So if you look at this graph here, it will look something like this. If I speed -2 right there. And notice that one full period was from 0 to pi. And we did one full rotation, meaning that we started and we ended at the same spot between 0 and pi.